So welcome back. Now we're going to continue on the right-hand side of assignment statements and talk a little bit more about some complexity about what you can do with these expressions. So all programming languages have various operators where you say, x plus 1 or x minus 1 or something like that. These operators historically come from the kind of characters that were on computer keyboards in the 1960s, literally. These things called teletypes came from the end of World War II, and they had a certain set of characters. And we were going kind of from mathematical character set, where multiplication is a big cross or a dot in the middle, and exponentiation is raising a little tiny number above it. And we just couldn't represent those on these really rudimentary key punches or rudimentary terminals. So we had to map mathematical formulas and functions into what could be done. And so those keyboards from, 40 years ago, 50 years ago, they had a plus on it, so plus is a plus. They had a minus on it, but multiplication, which is normally cross, is star, and division, which you can't put things on top of one another, so you just made a slash for division, and raising to the power is double star. Now the remainder operator is something that's not typically on calculators, but it's really important for computers, and we'll take a look at this. So the addition operator, pretty straightforward. I've kind of been using that without even talking about it. The multiplication and the division. So this is 5,280 divided by 1,000, which gives me 5.28. But the one that's probably the most interesting is this modulo or remainder operation. And so the way the remainder operation works is, in particular if this is an integer, is it does the division. So it's almost like a division, j divided by 5, but instead of giving the quotient, this is the quotient, it gives the remainder. So 5 divided by 23 is 4 remainder 3. The 3 is what you get back. Now you might ask yourself, why is this useful? So one of the ways to make this useful is to pick a large random number and then use the modulo operator, the remainder operator, with 52, and then you end up with a number between 0 and 51, and then you can pick a card. So you can take a random number, but you modulo at 52, and now you can have a random number that is a card. Or if you want to roll a dice, you make a big random number and you take it modulo 6, and then you can it tells you what side of the dice. So like games and stuff, there's other situations where you can do even and odd calculations, like is this an odd number, an even number, divide it by 2 and see what the remainder is. And so this whole notion of the modulo operator, it's really useful in some situations, and so that's why we obsess about it a little bit. The power operator, this is like 4 times 4 times 4, which is 64. So those are the numeric expressions. Now, these also have an order of evaluation, and the way it works is in mathematics there's order of evaluation. There are some operators that are more powerful than other operators. And you can always, if you're clever, just put parentheses in. And most programmers always put parentheses in. So if I was writing this line of code and I want it to be friendly to you so that you could read it more easily, I would simply put the parentheses in for you. So I'd say 5 to the 6th power goes first, then this 4 divided by that goes next, then this 2 times 3 goes next, and then we evaluate the rest of these things left to right. So I just added the parentheses that are the same. This is exactly the same as what it would be without the parentheses, because this happens first, this part here happens second, this happens third, and then all this other stuff happens fourth. So there's an order, but we're going to teach you what the order is if you weren't going to use parentheses. So the rule is parentheses override everything. Exponentiation is the most powerful. Multiplication and division and remainder are equal. They're the next most powerful in addition and subtraction. And then when in doubt, you just go left to right. So if there's a bunch of additions, you just go left to right. Or if there's an addition and subtractions and a bunch of stuff, you go left to right. Okay? So this is a classic exam question on computer science homework that you just say, okay, what does this evaluate to? Now, of course, if you have Python, you just type it in and it tells you what the answer is. So the way I used to do these back in the day when I was doing these homework is I would write the expression down on a piece of paper, and then I would look through it and I would figure out what the first thing was, and I'd be very careful about this. I'm like, okay, exponentiation happens first, so I'll do the 2 to the 3rd power, which is 8, and then I'll rewrite the whole thing, 1 plus 8 divided by 4 times 5, and then I would forget about this one and I'd look here and go like, okay, what's the first thing here? Well, 8 divided by 4 is the first thing there. So then I'd be like, oh, 8 divided by 4, well, that gives us 2. In this case, it gives us 2.0. And then I have 1 plus 2.0 times 5, and I look, and that's the next one. So that ends up being, actually, this ends up being 10.0, and that ends up being 11.0. And that's why this prints out 11.0. And so if there are no parentheses, you can figure out. Another kind of exam question is to ask what the parentheses would be. So the exponentiation happens first, the division happens second, and then actually you put another parenthesis because, you know, that result is multiplied by 5. And so that's another way to kind of answer the same question. Is say, put the parentheses in where they belong. Like I said, parentheses first, power second, multiplication third, addition, and then left to right. So when you got nothing but addition and subtraction, you go left to right. When you got nothing but multiplication, division, you go left to right. Start with the leftmost one. Sometimes it doesn't matter, but in addition and subtraction, it generally doesn't matter. But in multiplication and division, it can matter left to right. Okay, so we've been talking about variables, we've been talking about constants, we've been talking about expressions, but we also have constants that are integers, we have constants that are floating point numbers, and we have constants that are strings. And we can manipulate these. And Python carefully tracks not only what the value in a variable is, but what kind of a value it is. So is it a string, is it an integer, is it a floating point? And sometimes this makes a difference. And here's a little example code. We have this plus operator. And the plus operator is looking at its two operands, 1 and 4, is like, oh, those are integers. I know what to do with integers. That means addition. And so it adds this to be 5 and then sticks it into DDD, and out comes 5. On the other hand, we can actually use this same plus operator concatenating strings, because the plus operator looks to its left, looks to its right, says, oh, those are strings, and I know what you mean. I think you mean to concatenate this. And so then we end up with hello. The space is very carefully constructed right there because the plus doesn't add a space. So this ends up being hello space there, and that little space is the space here. And so Python knows the type of, in this example, these are all constants, but it ends up being hello.
DDD equals 1 plus 4, print DDD is 5. EE equals hello space plus there, print EEE That's how you print hello there. Concatenate equals put together.
Space there, and that little space is the space here. And so Python knows the type of, in this example, these are all constants, but it knows the type of constants and it knows the type of variables, and it can do very different things. And it can blow up and be unhappy, as we'll soon see, based on the type of things. So here we have an example of something that's unhappy. So I have now concatenated hello and
okay, Python knows what type of things. Some operations are prohibited. You cannot add one to a string. You can ask Python what type of function it by using the type function. You can ask Python what type function is by using the type function. Knows what type everything is. Okay, so EE equals hello space quotation plus there type EE. No, EE equals hello space plus there EE equals EE plus 1. That doesn't make sense. This is traceback error. Can't convert integer object into string implicitly. And so type EE is a class string, type hello is a class string, type 1 is an integer.
There, and then Python's perfectly happy to do that, and then I stick that in EE, and now I say I want to add 1 to it. It looks to its left, looks to its right, this is a string and this is an integer. And Python says, I don't know how to do that. Python could know how to do it, but it's chosen not to know how to do that. And so you get the dreaded traceback. And traceback is like syntax error. It is Python telling you, it's not Python telling you that you're a bad programmer or that you're never going to be a programmer or that you're completely unsuitable for a programmer. What Python is saying is, I, Python, am lost. You told me to do something I don't know how to do. You need to go remember what it is that I'm capable of doing as Python. Please come back and fix it. It also means that the program stops, meaning that if you're in a multi-line script and you're doing a bunch of stuff and there's a traceback here, the code after that quits, okay? And that's because you've hit this line that Python is lost and Python is loath to continue. Now, we'll see in a bit that you'll be able to force it to continue if you want, but because you said something that Python didn't understand, it just quits at that point. And traceback, line 1 in this case, tells you where it is that this thing blew up. And so this looks like nasty gibberish, but after a while, it won't take you long at all to just relax, look for the word traceback. That means Python quit somewhere. It tells you where, and then you look a little bit farther and it tells you what's wrong, type error. It's unhappy with the type, and it's still referring up to this line of code. It says, I can't convert integer objects to string implicitly. So it's like you have told it to do something, combining a string and an integer, and Python is like, I am lost. But I'm giving you as much clue as to how I got lost, what got me lost, where I got lost, where I got lost, and what caused me to get lost. And Python is trying as hard as it can to clue you into what's going wrong. So don't look at this as like bad. Look at this as like, oh, I'm not quite communicating to Python the way I want to communicate. There's a way to solve this. There's a way to do something here. And so if we take Python and we think about Python and say, hey, you're so picky and you blow up if I do the least little mistake on types, like help me out here. And so it turns out that Python has a built-in function called type. So again, it's type with parentheses. Function calls have parentheses on them, and we pass something in. And we're like, hey, Python, tell me what the type of the variable EE is. And then Python prints out, oh, it's a string. What is the type of the constant, quote, hello, quote? That's a string. What is the type of the constant 1? That would be an integer. And so Python keeps track of the value of variables and constants, the value and the type of it. And so we have to kind of manipulate this and be aware of this as we move forward. And so there's several types of numbers that we've already sort of been implicitly playing with. Like I said, you can give a variable to type, or you can give a constant to type. Variables and constants that don't have decimal places are integers, what are called integers, and variables that have decimal places are called floating points. Even if this was a 98.0, it would still be a floating point. As soon as you put the point there, then that means it's a floating point. They are represented.
Several types of numbers. Numbers have two main types: integers, whole numbers; floating points, which are basically decimals, which could also be negative, and so can integers. There are more number types. They are variations on float and integer, okay? There are other number types. Okay, XX equals 1. Type XX. It is a class integer. Temp equals 98.6. Type temp. Class floats. Type 1. Class integer. Type 1.0. Class float.
Internally differently. Floating point numbers have a greater range than integer numbers, but they are not always as precise as integer numbers. So floating point numbers have more range and less precision. So integers are perfect, but there's a limit, like 4 billion or 4 trillion or something. There's a limit. Don't worry too much about that. There is a choice that you make. You tend to use floating point numbers for things like temperatures or speed. Turns out that you don't use floating point for money. You don't use it for money, even though in our first examples we'll be bad and we'll use it for money. But shh, don't tell anybody that I'm using floating point for money. If you want, you can play with floating point and start finding some things where money goes bad. Okay, there's actually a number of different movie plots that have to do with computer programs that use floating point for money. I think Office Space is one of them that I particularly like, but there's other ones as well. Why you don't use floating point for money. I kind of got off track on that, but that's okay. So, we also have a set of built-in functions that can convert from one.
Okay, type conversions. When you put an integer and floating point in an expression, the integer is implicitly converted to a float. Okay. Okay. You can control this with the built-in functions integer and float. Okay, this is new. Okay, this is new to me. So, okay, print float 99 plus 100. Okay. Alright. I don't know why it's like print float integer plus integer, but okay. You could put in integer and floating point in an expression. The integer is implicitly converted to a float. Alright. It's 99 plus 100 would be 199. But since you're saying you want it to be a float, it will be 199.0. I equals 42. Type I is a class integer. F equals float. I print F. You turn the 42 into 42.0. Type F. F is now a float.
Type to another. There's float, there's int. And so float is a function. It again has parentheses. We pass in 99. So as this expression is being evaluated, it has to call float. It passes in 99, and then what comes back is 99.0, which is a floating point representation of the number 99. 99 and 99.0 are not the same. This is a floating point number. So when this addition happens, it produces 199.0. So that is a floating point 199.0. You are force converting by putting this, calling float, you are force converting that to a floating point number. If we look at like I is 42, we ask what type it is. Well, that I is an integer. We can take a variable and pass it into the float function and get back 42.0. That 42.0 comes back. And we say, what kind of thing is in F? Well, F is a float, right? So you can see how we're manipulating the type of things and controlling it. And anytime we get a little confused, we use the type function and say, hey, what's going on here? Why don't I understand what's going on here? Integer division is something that actually changed between Python 2 and Python 3. It's one of the bigger changes, the bigger non-upwards compatible changes between Python 2 and Python 3. And so this we're just reviewing. There are some things that were different in Python 2. So 10 divided by 2, even those are both integers, produces a floating point result. This makes doesn't make much difference in if these are evenly divisible, but if they're not evenly divisible, it makes a big difference. So 9 over 2 is 4.5. Think about like if you put in 9 divided by 2 in a calculator, you wouldn't expect it to say 4. And in Python 2, it said 4. It actually truncated. It actually threw this bit away. But in Python 3, it just automatically converts divisions to floating point, and so it works out quite nice. Okay, so 9 over 2 is 4.5. In Python 2, this used to be 4. And then 99 over 100 is 0.99, exactly what you'd expect in Python 3. In Python 2, that was a 0. Why? Because it truncated. It didn't even round the numbers. It chopped them off. So this was really quite a silly artifact of Python 2. In Python 2, if you get stuck in Python 2, you just use floating point numbers. And once either side of the division or any other operation is a floating point number, then the calculation is done in floating point. So if it's floating point input on either side, then it's floating point output. And this is what we used to have to do kind of in Python 2, is force things to be floating if we're doing divisions. It wouldn't hurt to do it in Python 3, but now integer division in Python 3 makes a lot more sense, thank heaven. Okay, string conversions. So if we read data, which we're going to see in a second, from the outside world, it comes in as strings. Whether we're reading from a network or from a database, we tend to get these things as strings. And so what we're showing here is
string conversions. You can also use int and float to convert between strings and integers. Okay. You will get an error if the string does not contain numeric characters. Okay. S-val equals 1, 2, 3. Okay. So that's a string, which is also an integer. Type S-val is a string. Even though it's an integer, it's a string because it has parentheses. Print S-val plus 1. And since S-val is a string, it cannot add an integer. So it's a traceback error on line 1. S-val equals 1, 2, 3. Can't convert an integer object into string implicitly. It's like, yo, if you want me to make this an integer, then take the strings away. Alright. Now, I-val equals integer S-val. Okay, so when you have a string and you want to make it an integer, you can say this equals integer variable type ival now becomes an integer. Okay. Print ival plus 1, now you get 124. NSV equals hello Bob. NSV equals integer. NSV doesn't make sense. It says line 1, invalid literal for integer with base 10x. I assume that means, I don't know why it says all that stuff, but I assume what that means. The issue that happened was, you know what I'm saying? I assume what happened was they try to convert an string to an integer without any numbers.
A string value that's 123, but it's not really 123. It's 3 characters. It might as well be A, B, C. So 1, 2, 3 are the first 3 characters. So we take this string constant, we put it in there, and we say, okay, what kind of thing is in there? It's a string. And if we try to add 1 to it, as we saw before, you add a string and an integer, and Python gets really unhappy. Can't convert int object to string implicitly. But what if we know that inside of this string are actually digits, and we want to get an integer representation or a floating point representation of that? Well, in that case, we can call the int function or the float function, passing in a string and getting back an integer. So this basically reads these characters, the 1, 2, 3, and goes, oh, that's 123, and gives us back 123. And we say, what kind of thing is in there? Well, now in ival, there's an int. Now I'm being mnemonic here. I'm remembering that this is an integer and this is a string, but Python doesn't care what I name my variables. Remember, Python never cares about what I name my variables. So if I start naming them conveniently, don't all of a sudden think that everything that starts with the prefix I is an integer and everything that starts with the prefix S is a string. It'll be a number of lectures before I stop reminding you of that. So, ival ends up with an integer, the number 123, and now we can indeed add 1 to it because it's an integer and Python's happy, and out comes a 124. So this works pretty well unless the string that in question has no digits. So there are no digits, it's going to blow up. It's like, whoa! Now, let's read it. Traceback means I quit. Where? Line 1. It's always line 1 because we're in this interactive environment. So, but if you were in a script, it would tell you what line it is. And then it says invalid literal for int with base 10x. And that's like, okay, it's not working very well. And so, say, oh, that's an invalid literal. And again, we'll find ways to cope with this in later lectures. Okay? Now, how do we get data from the outside world? So this is the keyboard. Eventually we'll talk to networks and databases and files, but right now we want to take the keys from the keyboard and get it into a variable. So we have another function, a special function, the input function. And when Python comes running in here,
we can instruct Python to pause and read data from the user using the input function. Different functions in Python. Okay, functions are the things you want Python to do. The input function, one of my favorite functions, it it opens up the ability for users to input things into Python. Another way of saying that is Python may ask it to ask the user to type in something, I'm saying, and then based on whatever it types, it'll be able to finish the code. This is early in the beginning, but I'm saying it's starting the clock.
It starts the input function, and the parameter to the input function is what's called a prompt.
Who are you?
It prints out, who are you, and then it waits. And then
Welcome.
we type into the keyboard, Chuck, and then we hit the enter key, and then it takes this string right here, and then it puts it in this variable right here. It is a string. Even if I typed in 1, 2, 3, 4, it would be the string 1, 2, 3, 4, not 1,234. Okay? And so that is the way. And so this program at this point pauses until we type and we hit the enter key, and then it takes that line of input, including spaces, whatever I've typed, and puts it in that variable. And then the program continues. And in this case, it just prints out welcome, comma, and then the contents of the variable NAM. And in this case, this space right here that you see between welcome and Chuck, that is caused by this comma. So we mostly seen printing one thing, but you can have as many things as you want with commas in print, and every comma adds a space, and so it's kind of friendly. If you wanted to, you'd have to concatenate these things together to eliminate that space. But most commonly, you're printing out a list of things, you probably want spaces between it. Okay? So that's how we read input. Up next, we're going to combine all these things, and we're going to make our very first program that does actually something useful. So we'll see in a bit.
Nice.
So now we're going to combine everything in the previous lectures, and we're going to actually make our first program. So
Something just happened. Now I look weird again. I don't know why the contrast just went up like that. But now I feel like I look green.
Before we make this program, we need to talk a little bit about documentation. We talked about mnemonic variables as a friendly thing for humans. Another thing that's a friendly thing in programs for humans, and you will tend to realize that the human that you're being friendly to when you're writing code and you're doing it well is yourself. So good variable names are going to help you a lot. They might help your teaching assistant, but they're also going to help you. And comments. Comments are a way for us to add text that's ignored by Python to our programs. And so it's a great way to give a little idea what's going on in code. Maybe there's a couple of lines coming up that are 10 lines long that's a little complex, and you want to say, oh, all this is really doing is reversing the order of these two things, or who knows what. Or you might document who wrote the code, and you can actually just take a line of code and put a pound sign in front of it, and then instead of deleting the line of code. And sometimes you do that for debugging. You add debugging code, and then when you don't want the debugging code, you just put a pound sign in case you want to take the pound sign out to turn the code back on. So I use it as a way to turn it off and on lines of code. So here is our word frequency that we keep coming back to. And what I've added here is I've added 4 comments. I've added comments that basically help us understand what's going on. And remember, I call these like paragraphs. Our first paragraph has human readable code, human readable text. Get the name of the file and open it. That's what's going to happen in the next 2 lines. These next 5 lines are count the word frequency. Maybe I should say make a histogram. So make a histogram, and you can just read this. And so again, don't think of this as like the teacher's telling you that you got to write comments. Think of this as like, I'll write comments so I remember what I was doing here. Why did I write this code? So write the comments to help yourself out. And now here, the last thing, we're all done and we're printing the stuff out. Okay? So that's comments. It's an important part of documenting your code so that you can figure it out later. And again, the human who's going to like you for doing all this stuff is you. Right? So you, this is you, and you're giving a gift to the future you. Right? So you are writing comments so that the future you can read the comments, because in a day or a week or a month, you won't quite remember what you were doing, so go ahead and write comments. But don't write them because I said so. Write only the ones that you find useful, and don't do something like x equals 1, pound sign, put 1 in x. That's kind of silly. I mean, everyone can figure out what x equals 1 means. So you don't put silly comments in just for silliness. You just put them in so that you can, especially when you have to understand what's going on here, so that people don't have to read quite so detailed. And one of the things they would do is they would read this and check to see if it really did what you said it was going to do to help you debug it, for example. So that's comments. Documentation, very important. Okay, so now we're going to do our first programming code. Now, the pattern that's going to happen in here is a pattern that I call, and I was taught 25, 30, many years ago, input, processing, and output are the essential things that computers do. They gather some input, maybe from a file or from a web service. They do some work to it, and then they produce something. In, work, out. The work is the hard part, usually. And so this program is our first program that demonstrates all 3 of them.
User input. If we want to read a number from the user, we must convert it from a string to a number using the type conversion function. Later we will deal with bad input data. Convert elevator floors. Input IMP equals input European floor. USF equals input USF equals integer IMP. Okay. Okay. I need for you to, okay, so we want to convert elevator doors. Okay. We want to convert elevator doors. Okay. I need for you to elevator doors, okay. European elevator floors, excuse me. Okay, so it's a European floor is our IMP equals whatever you say it is. Alright, but it's going to be the Europe floor. Okay? So when you go to input, it's going to be like, what's the Europe floor? Alright. Next thing. US.
Those things, input processing.
Is going to be an integer of +1, and it's that way because that's the way it is. Typically in Europe, they have a 0 floor and we have a ground floor because Europeans are weird. Okay, so we have an extra floor, and so in order to represent that extra floor, we add 1. Okay, now we can print US floor space, which is a comma, USF. Okay.
An output, and it's a 3-line program with 1 comment. So the problem that this program is trying to solve, for those of you who have traveled in the US and traveled everywhere else, is that the ground floor in hotels in most of the world is the 0 floor, and the ground floor in the United States is the 1 floor. And so you might find yourself in a European elevator asking what is the equivalent United States floor to this floor that I'm sitting on? So if I'm on floor 7, what would be this floor if I was in the United States? And that's the problem we're going to solve. Now, it's probably not going to make us rich if we build an app for this, but perhaps someone can get the European Elevator Converter app into some app store, and maybe you will get wealthy after all. But for now, it just is sufficient to teach us about a full-blown program that does input processing and output. It's as simple a program as I could make. So let's take a look at it. A comment. Convert elevator floors. That has nothing to do with Python, has to do with you or me reading about this. Then input. Well, remember, input prints out the prompt and then pauses and waits. And then we type, and then we type the enter key, right? And then this 0, this is a string. The string ends up being input in the variable imp. And then it continues.
Okay, so then we say USF equals integer INP I can type a string to ask them what to input, and then I create a variable to equal the integer that they give me. Of that string and add it. And I want them to print the US floor space USF.
To the next line, and it works on the right hand side. We're going to pull this string 0. We have to convert it to an integer, otherwise we can't add 1 to it. If we just int +1, we'd get a traceback. But we say int of imp, convert it to an integer. Now, if you mess this up and put Bob in, then this thing is going to blow up because int can't convert Bob to an integer. But because we have a 0 here, we're okay. So then we add 1 to it and store that in USF. USF, mnemonic variable name, United States floor, imp, the input we got from the user. I'm using good variable names here. So we store this in, and so, we got that becomes 1, and then we print out US floor, comma, USF. Remember, the comma produces this little space down here. And so we have our input, processing, and output in a way that builds us an application. Okay? Now, there's lots of things left to do, and most programs aren't one line long, and there's a lot of work that we're going to have to learn, but this gets us a start. So, we've talked a lot of stuff. We talked about constants, we've talked about variables, we've talked about reserved words, we've talked about type, we've talked about mnemonic variable names, which are both wonderful and a little confusing at the same time. Operators, operator precedence, focus a little bit on division, where we talk about Python 2 versus Python 3, type conversion and comments, and then writing an entire program. So up next, we're going to start talking about conditional execution using the if and the else and other of the reserved words. And this is where some of the intelligence starts to seem to come into computers. So up next, conditional execution.
Up next, conditional execution. So I'm retaking this because last time I took it, I cheated. Alright, so which of the following is a comment? That's a comment. What does the following code print out? 1, 2, 3 plus ABC. Maybe you'll print out that. Okay, you cannot add strings. Which of the following is a bad variable name? This one. Which of the following is not a Python reserved word? Iterate. Assume the variable. I don't know. really don't know. But I think it's worth testing out. See, I'm gonna have to go to Gronk. Okay. Okay, so it truncates it. What does the Python input? So pause the program and read data from the user. Connect to a network, read a memory, take a screenshot. Alright, let's see what I got. I think I got like an 80. 90. Okay. So what's the answer to this? So it might just be 1, 2, 3 plus ABC. One, two, three, ABC. Okay. Got it. Alright, let's do this assignment. Write a program that uses input prompt for their name. Hello, Sarah. Name equals input your name. a program to prompt the user for hours and rate per hour using input to compute gross pay. Use 35 hours and a rate of to test the program. The pay should be. You should use input to read a string and float to convert the string to a number. Don't worry about error checking or bad user data. Hours. Rate equals I need to convert that string into an integer. Plus r divided by seven five. Oh, 35 hours. You should use the built-in float function to convert from a string to a float. Oh, okay. Rate equals float. $35. To multiply the pay and rate after you read them, divide, multiply. Oops. $35. You should not include the input data into your source code. You must read the values for the rate and pay using input. How is that a mismatch when I got... Oh, okay. I mean, I can do that. I can do this right here. Print. Pay. Syntax error, bad input online. off. Boom. You should not include the input data in your source code. You must read the values for the rate and pay using input. Oh, wait, should I do? I do times 0.75. And then hours equals float hours. And then print pay hours. What about that? Type error. Can't multiply sequence by non-integer of type float on line 3. Okay. Wait. Times 2.75. 35. Wait. 35. Can't multiply sequence. include the input data in your source code. Okay, so I put 35, input 35, float 35, 35 times 2.75, pay equals rate, 35, boom. You should not include input data in your source code. You must read the values for rate and pay using input. Write a program to prompt the user for hours and rate per hour using input to compute gross pay. Use 35 hours and a rate of. The pay should be. You should use input to read a string and float. String to a number. Alright, equals float. You should not include the input data in your source code. You must read the values for the rate and pay. Read the values for rate and pay using input. You should not include the input data in your source code. sequence of non-integer type float one for. Does not include the input data in your source code. You must read the values for the rate and pay using input. I'm literally getting what I want, but it's something I want. Okay, so let's go. Wait, 2.5. Pay equals bro. What the fuck? Rate equals M put rate. Enter rate. last time when I figured this out, hours rate equals input enter rate per hour. A equals float. Okay. See, I'm not that far off, bro. Enter rate 7.5. Oh my fucking goodness, bro. So many ways to come up. Let me go ahead and go to bed. Okay. Shut me up to sleep. Nice. 10K stretch. Yeah, it's time for me to go to bed. 3:30 in the morning. Leave a like, follow, sub up. Appreciate y'all, man. We gonna learn how to code the right way. Alright. Awesome.